So actually it comes in the fourth module. Okay, so anyway, so it is used for solving the optimization problem. That is, we want to find the optimal solution to a complex problem. Okay, we want to find the optimal solution to a complex problem. In such situations, we can use uh, this type of approach. Okay, this approach, dynamic programming approach. Okay. So so in the previous class we discussed about the basic approaches. So which are the different steps, or what is the control abstraction used here? First we will divide the problem into subproblems. Okay, first we divide the problem into subproblems. Then what we will do? We will try to find the optimal solutions to, you can note there, we can try to find the optimal solution. Okay, dynamic programming is used to get an optimal solutions to a complex problem. Okay, so the approach is divide the complex problem into complex subproblem. Find the optimal solutions to these subproblem. Then store the result of subproblem. This is called a memoization. So for storing the intermediate result, we need a data structure. Okay, we need an additional data structure in this method. Okay. Okay. So next is reuse. Fourth step is reuse. That is, reuse the result of subproblem. Reuse the result of subproblems. Okay. So by using the reuse, that is, so no need to solve the subproblem again. That is the use of the reusing. Okay, 1 minute. That is the use of okay, 1 minute. Okay, that is the use of reusing. So what is the use of reusing? So reuse the result of subproblem. Okay, then we finally calculate the complex problems by combining the solutions of the subproblem. So this is our approach, and basically we need a divide method. Then we need a mechanism to divide the subproblem. We need a storage for memoization. Okay, that is table storage. And combine, we should need a mechanism to combine the result. Okay, we should need a mechanism to combine the result. So these are the this is about the control abstraction of this dynamic programming approach. In the university exam, one question they asked. Okay, so next okay, next we are going to discuss a problem that is called a chain matrix multiplication. Okay, so next we want to discuss a problem, chain matrix multiplication. Okay, chain matrix multiplication. Chain matrix multiplication. Okay, chain matrix multiplication. And Okay. Chain matrix multiplication we want to discuss. It is a complicated problem basically. That is matrix multiplication. We know how to multiply two matrices. Okay, but we want to multiply more than 10 matrices. But we want to multiply 10 matrices or a lot of matrices one by one. Then in that situation is called chain matrix multiplication. Okay. Okay, that is called chain matrix multiplication. So we can go to that concept. So chain matrix multiplication is an optimization problem. Chain matrix multiplication is considered as an optimization problem. Okay. Chain matrix multiplication is an optimization problem. Okay. So what is chain matrix multiplication problem? That we want to discuss at first. Okay. So here we can define the problem in this way. Chain matrix multiplication is an optimization problem. So it can be considered as an optimization problem. So we want to find the best solution, okay, in terms of the complexity. That is, given a sequence of matrices, we want to find out the most efficient sequence to multiply it. Okay. For example, suppose you want to multiply four matrices in this way. Okay. There are four matrices A1, A2, A3, A4. Okay. Okay. There are four matrices A1, A2, A3, and A4. Okay. You can note the order also. 5 by 4, 4 by 6, 6 by 2, and 2 by 7. So we want to multiply all these matrices. Okay. So we want to multiply all these matrices. That is not a problem. Okay. But what is the problem here is that it should use, what is the actual problem? What is the optimization problem is that we should use minimum number of scalar multiplications. Okay. So we want to multiply four matrices. Sure, we will get an answer. That's not a problem. Okay. But here we should use minimum number of scalar multiplication. Okay. We should multiply these four matrices using minimum number of scalar multiplication. What is scalar multiplication? What is scalar multiplication means? Scalar, that is our ordinary multiplication, 4 into 5. For example, 4 into 5. What is 4 into 5? 4 is a scalar, 5 is a scalar. So this operator is a scalar multiplication operator. Okay. So we want to multiply these four matrices with the minimum number of scalar multiplication operation. That is the problem. Okay. So if you think about this problem, so this is the chain matrix multiplication problem. Okay, there are a lot of matrices. For example, A1, A2, A3, etc., A4. and with some order. Okay, so we want to multiply these matrices in some sequence with the minimum number of scalar multiplication operations. That is the chain multiplication problem. Okay, and try to understand this concept. This is somewhat sometimes it will be difficult to understand, so please concentrate on the concepts. Okay, so this is our problem now. Okay, this is our problem. A1, A2, A3, A4. I want to multiply these matrices with the minimum number of scalar operation, scalar multiplication operation. Okay, so you can note here in how many ways I can perform multiplication here. For example, you can note first I can perform A1 into A2. Okay, then first I will perform A1 into A2. Okay, then I will perform this result is multiplied with A3. Okay, okay, then that result is multiplied by A4. This is one sequence of multiplication. Okay, so this is one sequence of multiplication. Okay, 1 minute. Shraddha, Sarang, is it okay? Any net connection problem or anything?
Yes, sir. Okay.
Okay, okay. So this is one sequence of multiplication. Okay, that is first I will perform A1 star A2, then I will parenthesis it. Okay, then I will perform this result is multiplied with A3. Okay, then that result is multiplied with A4. Okay, then this is one possible type of multiplication. Okay, so another type of multiplication is, another sequence of multiplication is this. Okay, so you can note here the tree also. Okay, this is the corresponding tree for performing this multiplication. Okay, similarly I can perform this sequence. A1 star A2 is performed, then A3 star A4 is performed, then this whole is multiplied. Okay, that also possible. Then this will be the corresponding tree. Okay, so in this way I can perform different sequence of multiplications. Okay, so the thing is that this sequence of multiplication will take some number of scalar operations star. Sometimes suppose it is C1. Okay, then this multiplication sequence will take some number of scalar multiplication. Suppose C2. Okay, C2. Then our problem is find out which one is better. Our optimality problem is, or optimal chain multiplication problem is, which of this multiplication is the most efficient. Okay, so that is the problem. Okay, so we should find a way to find, we should develop a way to find out the best multiplication sequence that will take a minimum number of scalar multiplications. Okay, so In general, this is not very important. In general, if you consider n nodes in a tree, then you can create uh, this number of trees. Okay, so if n is equal to 3, there are 5 trees possible, and we should here I drawn only 2 trees. This is one possible type of multiplication. This is another type. Then next, etc. is there. 3 more other type is there. Okay. Then the problem is find out which one of them is contains minimum number of scalar multiplication. That is the problem. That is chain matrix multiplication problem. Okay. So in this case, there will be 5 trees. I drawn 2 only. So which one will be the most efficient sequence of matrix multiplication? That is the problem. That is the problem. So we can use dynamic programming approach to find out the optimal sequence of multiplication. What is optimal sequence? What is meant by optimal here? Here the minimal number of scalar multiplication operations needed. So this is about the chain matrix multiplication problem. Okay. So sometimes in the exams, they may ask the basic question, explain the concept of chain matrix multiplication with an example. Okay. So we should define what is chain matrix multiplication problem. Then give an example. For in this case, there are 4 matrices, and these 4 matrices can be multiplied in different sequences. This is one sequence, this is one sequence, etc. And each sequence will take different number of scalar multiplication. Okay, different number of scalar multiplication. Okay, that is very important. That is very important. Scalar multiplication, the term scalar multiplication. Okay, it will take a different number of scalar multiplication. So we want to find which sequence will contains minimum number of scalar multiplication. That is the chain matrix multiplication problem, and we can use dynamic programming approach to find out the optimal sequence of multiplication. That is the what is meant by optimal, the minimal number of scalar multiplication. I didn't added it, but it actually means scalar multiplication. Already I introduced what is scalar multiplication. Our normal multiplication of 2 values is called scalar multiplication. Okay. So that is about the dynamic programming approach problem. That is chain matrix multiplication, and this problem can be solved using dynamic programming approach that we will discuss later. Okay. Now, before discussing, I ended here. We can use dynamic programming approach to find out the optimal sequence of multiplication. Okay, there is a way. Okay, there exists a way. Before that, I am introducing some basic concept of matrix multiplication. Okay, then only we can understand how dynamic programming approach will work. Okay, so I'm considering 2 examples. Okay, first case is A. This is a matrix A. Its order is 2 by 3. You can note the order. Okay, 2 by 3. Another matrix B is there, and the order is 3 by 2. Okay, and the order is 3 by 2. So what should be the basic condition for multiplication? This should be same. Okay. So if you want to multiply these 2 matrices or any 2 matrices, this order should be same. This dimension should be same. Okay. So in this case, 2 by 3 and 3 by 2, this is matching. 3 is matching. This is our basic concept. 3 and 3, this is matching. So we can multiply and we will get a resultant matrix. What will be the order of resultant matrix? It is 2 by 2. Okay. So this is very important then for understanding dynamic programming approach. Okay. So this should be same, and the resultant matrix C, it's what is its order? Its order is 2 by 2 because this one 2 by 2. Okay. So this is the basic our approach and rule. Okay. Now how many elements will be in the matrix C? How many elements in the matrix C? There are 4 elements. Okay, it's a 2 by 2 matrix. 2 by 2 is 4. There are 4 elements. So which are the 4 elements? This is one element, this is second element, this is third element, this is fourth element. Okay. So how can get this element C11? How can get C11? C11 is obtained by multiplying first row with first column and adding. Okay, you can note here first row, first column. Okay, so A11 into B11 plus A12 into B21 plus A12 into B31. Then you will get C11. Okay, fine. Similarly, how can get C12? Similarly, we can find out the other elements. No problem. That's not an issue. This is our basic matrix multiplication. But the important thing is that for finding out the C11, how many basic scalar multiplications needed? How many scalar multiplication needed? Okay. So we are interested in finding the number of scalar multiplication. So my question is, for finding this element C11, how many scalar multiplications needed? This is one scalar multiplication. This is 2. This is 3. Okay. So for finding this, I need 3 multiplication. 3 scalar. Then for finding this also we need 3. So what will be the total number of multiplication needed? Okay, my question is simple. So 3 scalar multiplication is needed to find this element. Okay, there are 4 elements in this set, in this matrix. So we can find how many scalar multiplication needed. This is 3, this is 3, this is 3. In total, it is 4 into 3, which is 12. Okay. So performing this multiplication, this 2 matrix multiplication, A and B, we need 12 scalar multiplication operation. Okay. We can find this in this way. This is very, very important. Okay. So here to find all the elements of C, we need 12 multiplication. How it came? In this way. Okay. You can note here, this 3, you can note here, this 3 and this 3. The order of this and this is same. So we know we can discard this, any 1 3. Okay, this 3 and this 3 is same, so we can discard 1 3. Okay, so suppose I'm discarding this one. Okay, then 2 by 3 into 2. 2 by 3 into 2, that is 12. Okay, In this way, we can find out how many basic scalar multiplication needed to multiply two matrices. Okay, using this concept, you can find. Okay, so this is the basic concept you should study before studying dynamic programming approach. Okay, so now I am going to the example 2. Okay, case 2. Okay, so suppose there are two matrices 2 by 2 and 2 by 2. Then the basic concept is this should be same, then only we can multiply. Okay, so how many, for finding there will, how many elements will be the 2 by 2? So 4 elements is there, and this will be the elements. Okay, for finding this element, how many scalar multiplication needed? Here, 2 scalar multiplication needed. Okay, you can observe here. You can observe here. Here, 2 scalar multiplications needed. Okay, so in total, how many will be the 4 into 2, which is be 8. Okay, so how this 8 comes? Because 2 by 2 into 2. Okay, 4 into 2. Okay, it is 8. Okay, so we got this idea. So this idea is necessary for understanding the dynamic programming approach. Okay, so now I am going to discuss a simple problem. Consider the below example. In the university exam also you can expect this type of questions. Okay, so consider the below example. Find out the number of multiplications needed. Okay, so there are 3 matrices given. Sometimes in the exam it will be 4, sometimes 5, etc., etc. So here the problem is basically simple. Okay, here only 3 matrices are there. So the question is find out the number of multiplication needed. Okay, find out the basically it is optimal. Okay, we can check. Find out the number of multiplication needed. Okay, there are 3 matrices given and its order also given: 2 by 3, 3 by 4, 4 by 2. So in how many ways we can multiply it? Okay, in how many ways? This is the sequence: a1, then a2, this is a3. Okay, this is the sequence: a1, a2, a3. In this sequence, how many ways I can perform multiplication? And for each multiplication, for each type of multiplication, I want to count the number of basic scalar operation. Okay, so which one will be the first type? For example, this is, you can note, I can perform in this way: a1 into a2. I multiply this at first. Is it possible? Yes. Why? Because this is 3. Okay, you can note here. These are equal. So I can multiply. No problem. Then I will perform this at first. Then I indicate in this. I parenthesis this. Okay, because I'm performing this at first. Then the result of this is multiplied with a3. This is one possible multiplication. Okay, so you can note how. Okay, I'm concentrating on this now. Okay, so next, is it possible multiplication? Yes, because we want to multiply 2 by 3. The order of a1 is 2 by 3 and the order of a2 is 3 by 4. Okay, so these two are same. Okay, so I can multiply, then I will get a matrix 2 by 4. Okay, then this 2 by 4 matrix is multiplied with a3. What is the order of a3? a3 is 4 by 2. So a3 is 4 by 2. These two are equal. Okay, these two are equal. That is, then I can multiply, then I will get a matrix 2 by 2. So this sequence of multiplication is possible. Okay, this sequence of multiplication is possible. Now I want to find out how many basic multiplication operation needed. Okay, for example, as I told, which multiplication I will do at first? This one, a1 star a2. Okay, I will perform this multiplication at first. So for performing a1 star a2, how many basic operation needed? A1 star a2, for example, it is C now, and it needs, you can observe this, 2 by 3 into 4. Okay, this is our basic concept. That is, if I want to multiply this, 2 by 3 into 4. This number of basic multiplications will be needed, that we discussed in this section. Okay, let's be discussed here. Okay, I hope you can get the idea, this concept. Okay, by using this concept, we can find out the basic number of multiplication needed, which is 24. Okay, for performing a1 star a2, 24 operations is needed. Then this is multiplied with a3. That is, C into a3 we want to perform. Okay, that is, we want to multiply the result of this. This is C. Okay, this should be multiplied with a3. Okay, so now what is the order? C's order is 2 by 4. Okay, which should be multiplied with a3. A3 is a 4 this order is 4. A3's order is 4 by 2. Okay. Hello, okay. Hello, Masna. Okay, la.
Sir, okay.
Okay. This order is 4 by 2. This is 2 by 4. Okay, this is 2 by 4. This is 2 by 4. So, how many multiplication operations needed? 2 by 4 into 2. Okay, that is this. 2 by 4 into 2, 16. What total? We need 40 basic scalar multiplication. That is, the moral of this concept is, if I multiplied in this sequence, then I need 40 scalar multiplication. Okay, this is one order possible, then 40 is. Similarly, I want to try this one. This is another possible multiplication order, because if I arrange it in this way, then this is 2 by 3, 3 by 4, 4 by 2. I can multiply this at first, then I will get 3 by 2. This I can multiply with this, because these two are same, so I can get 2 by 2. So for performing that, I need, similarly, I computed in this way, and it's need 24 plus 12. Okay, I'm not explaining how it come. Okay, so concept is simple. For performing A2, A3. Okay, A2, A3, A2 is 3 by 4 and 4 by 2. So 3 by 4 into 2, 24. Okay, then the resultant is 3 by 2. 3 by 2 and 2 by 3. So 2 by 3 into 2. Okay. So 2 by 3 into 2. It is 24 plus 2 is 36. Okay. So which will be the efficient? These are the two orders possible. Okay. Try to find out some other order, but it's not possible. These two orders on, and these two sequence only possible in this case. Okay, so one or sequence will take 40 scalar multiplication, another is 36. Which will be the efficient one? Which is this one. This will be the efficient one. Why? Because it will take minimum number of scalar multiplication 36. Okay, so this is a chain matrix multiplication problem, and if we do it manually, for example, if I am considering a4, this is a simple case. So I done it manually. Suppose there is another matrix as a4 or a5 or some other number of matrices, then I want to try all these possible ways. Then I want to calculate the uh, cost of each way manually. Okay, then from that I want to find out the best one. Okay, so that will be an extremely complex process. For example, if there are 10 metrics or 100 or 20, etc., etc., the problem will become a very complicated process. In that situation, I can use the dynamic programming approach. Okay, so here I told which will be the optimal one, this one. What will happen if number of matrices in the chain increases? The problem become very complex. We need the dynamic programming approach based solution that we can discuss in the next class. Okay, okay, okay. Then please give your attendance in the chat box. Okay, starting from Akash Rajiv. Okay, okay. Kanaka Anjali. ദിൽന ദിൽന ആബ്സെന്റ് ആണോ? ഓക്കെ. ഹസ്ന ജസ്ന. ഓക്കെ. കാർത്തിക് കീർത്തന. സിനാൻ ഇജാസ്. ഇജാസ്. ഓക്കെ. Then Pranav, Pranav C. Sorry, Nafa, Neha. Pranav, Nitin Babu, Pranav, Pranav C. Okay. Pranav C. Pranav C absent ആണോ? Pranav C. Pranav C absent ഇടുന്നുണ്ട്. ഓക്കെ. ഓക്കെ. റൈസ, റസാന, റോഷൻ, റിസ്വിൻ. റിസ്വിൻ ആബ്സെന്റ് ആണോ? ഓക്കെ. സഹ്ല ബി. ഓക്കെ. സഹ്ലാൻ. ഓക്കെ. സംഗീത്, സാരംഗ്, ശ്രദ്ധ, ഷാരുൺ. ശ്രദ്ധ. ബേബി ശ്രീഷ്മ, വിഷ്ണു, വിനോദ്, വൈഷ്ണവി, അഞ്ജിത. വിഷ്ണു ആബ്സെന്റ് ആണോ? ഷിറോണ ആബ്സെന്റ് ആണോ? വിഷ്ണു ആൻഡ് ഷിറോണ. So the absent is Vishnu, Shirona. Okay. Pranav C. Okay. Okay. Thank you.